Hello, this is Mr. Miller and welcome to video number 0170, Systems of Linear Equalities. Hello, this is Mr. Miller and welcome to video number 0170, Systems of Linear Inequalities. We're going to study how to draw graphs like this that show the intersection of two inequalities. Okay, but first, let's review how to graph just one linear inequality in the plane. Turns out that whenever we graph a line, we're dividing the plane into three parts. Here we have the line x plus 3y equals 6. And every point on this line has the property that the x-coordinate plus 3 times the y-coordinate equals 6. But if we changed it to x plus 3y greater than 6, we will get all the points above the line. And if we changed it to x plus 3y less than 6, all the points that satisfy that are below the line. So the line is where the points are equal to the constant 6. If we switch it to greater than above and less than, it's below here. So when we want to graph a linear inequality, there's two basic steps. The first step is actually to graph the boundary line. And then the step after that is to decide which side of the line is the side we want for the inequality. Okay, so for this one, y greater than 2x minus 3, the first step is to graph the equation y equals 2x minus 3. So to graph that, we see that the y-intercept is negative 3, so that gives us a point to start with. And the slope is 2, so we went up 2 over 1, up 2 over 1 to get a few points. And then we drew the line here. So these are all the points where y equals 2x minus 3. Now, we drew it a dashed line because our original inequality does not include the line. So if it's just less than or greater than, you want to draw a dashed line. That means we're not actually including those points. If it's greater than or less than or equal to, then we draw a solid line. Alright, so that's why we have a dashed line here. Our inequality is for points that are greater than, where y is greater than 2x minus 3, not equal to. Alright, so once we have the borderline, we just got to decide which side corresponds to points where y is greater than 2x minus 3. Well, one way to do that is to try a test point. We'll see if the point 0, 0 works in the inequality. And if it does, this is the correct side to shade. If it doesn't, we shade the other side. So I'm just going to put 0, 0 into this and see if it's true. So I put 0 in for y. I'm going to substitute 0 for x. And we get 0 is greater than negative 3, which is actually true. So this is the side that belongs to this inequality. And right here, this is the final graph. Okay? So again, the points on the boundary line where it's equal to, y is equal to 2x minus 3. This is where it's greater than 2x minus 3. This side would be where it's less than 2x minus 3. Alright, so here's another example. This time we have y greater than or equal to minus x plus 2. So again, we're going to start by graphing the boundary line. And we see that the y-intercept is 2. The slope is negative 1, so we're going over 1, down 1. Alright, to get a few points, and then we draw the line. This time it's solid because we have greater than or equal to. We want both the points that are equal to minus x plus 2 and the ones where y is greater than minus x plus 2. Alright, so that's why we have a solid line here. Now, let's try this again. Let's try to put in the point 0, 0 and see if that works. So when we do that, we get 0 greater than or equal to minus 0 plus 2. Which gives me an inequality 0 greater than or equal to 2, which is not true. So 0, 0 doesn't work, and neither does any point on this side. We know that the correct side to shade is this side. So we have all the points on the line and all the points above the line in this case. Alright, there's one last thing I want to review with you, is sometimes the line is not in slope-intercept form. So I just want to remind you of the intercept method. So what I'm going to do in order to graph this boundary line is I'm going to find the x and y intercepts. often I like to make a little table. I'm going to put 0 in for x. When we put 0 in for x, we get minus y equals 4, or y equals negative 4. That's this point right here. That's where that came from, the y-intercept. Then I'm going to put 0 in for y. When I put 0 in for y, I get 2x equals 4, or x equals 2. That's the intercept method of finding 2 points that belong to the line. And now we can draw the line. Now, I see I made a little mistake here. This line should be dashed. So I'm going to kind of correct that, make this a dashed line. So that was my bad. Then if we put in 0, 0, we get 2 times 0 minus 0 is less than 4, or 0 less than 4, which is true. So we shade this side with 0. And again, this should be a dashed line. That was a quick review of graphing linear inequalities. Now we're going to graph a system of inequalities. We're looking for all the points that belong to both of these. So the way it kind of works is we graph one inequality. This inequality right here is the first one, y less than or equal to 2x minus 1. That's this region right here. Then we're going to graph the second inequality. That's that one. That's the one with this red region here. And the goal is to find the part that belongs to both. So our final graph in this case would look something like that. This region right here is the part that belongs to both. That's called the intersection, what belongs to both graphs. Alright, so here's how we do this by hand. First, we graph the first inequality. Y greater than or equal to 3x minus 1. Okay, that's this line right here, and it's solid because it's greater than or equal to. If we put in the point 0, 0, we get 0 greater than or equal to negative 1. It works. So instead of shading this, because that's going to get really messy, it's one thing when Desmos does it, but it's hard to do this with shading by hand. I'm just going to draw arrows to show that we want this side of the line. Okay, so in this diagram, the first inequality, we want to the left of the line. Now, the first step is to draw the first inequality. The second step is to draw the second inequality. So we draw the second line, and we got to decide which side should be shaded on that. 0 is less than or equal to minus 0 plus 3. Actually, that's true also. We want the side with 0, 0 here. So, to make it a little simpler, let's draw arrows on there. And we want the region that belongs to both inequalities. We see that that's this region right here. So, if we're doing this by hand, what we would do is shade this region right here. There are 4 different regions formed by the 2 lines, and we want to pick which one satisfies both inequalities. It turns out that this one does. This is the one where both the arrows for both lines point to, right there. Okay, let's try one more example. Here we have y greater than 2. Well, y equals 2 is a horizontal line, and this is purple dashed line. So we want above this line. Y greater than 2 means above 2. All right. Then we graph the second inequality. This right here is y equals x plus 3. If I put in 0, 0, it's not true. We get 0 greater than or equal to 0 plus 3. So we want above this line, which gives us this region right here. So above the purple line and above the green line. Okay, so that was a real fast tour of these. But basically, to graph a system, you graph both inequalities, see which part belongs to both. All right, let's see how you do it. Go ahead and complete assignment number 0170, Systems of Inequalities, and submit it, and I'll be glad to give you feedback on it. Take care.